write these clients using object-oriented programming like we did for everything else before. So that script may be quite useful for you if you just want to quickly call the server and put some more logic into the code. But the big problem here is that you need to call, it's with this line, you need to call rclpy spin until future complete, okay? And when you are inside a node with a class, for example, let's go with the number counter, when you are already spinning the node, well, you should not call another spin functionality from within the node, okay? So you will not be able, you should not call spin until future complete when you are already spinning inside the node. So how can you wait for the future? And that's what we'll see right now. So let's go to our add2int client where we will use object-oriented programming, and we will again copy and paste that. Okay, add to int client node. Okay, and add to int client. So we will actually reuse most of the code from there. That's why I started with that. So first of all, we need the same dependency here. And now what we'll do is we will create a function to call the server. Okay, so I create a function so we can actually later on we can call this function multiple times. Call add to int server. Okay, and we will give a and b as a parameter. So in that function we will create the client, we will create the request, and we will call the server, and also then see how we can wait for the response. So the first thing we need to do is the same as here, is to create the client and to wait for the server. So I will copy and paste that here. So client, it's not node here, it's self, because we are in the class. Self create client with the add to int service type and add to int name. While the client is, so while we wait for the service, we print again self get logger a warn message. Okay, and now we can be sure that the service is up. So then we need a request, and that is the exact same thing here. Requests. Okay. But here, of course, instead of the hard-coded value, we will use what we got here, A and B. And now we can call the server. Okay, so we will use the same line here. So we call the server asynchronously, we send the request, and we get a future. So now how do we wait on that future? So in Python, it's not possible to simply wait on that future on this thread. You will have to use some other libraries like async.io, for example, but I will not go into that way. And you will also maybe need to use different thread, because if you are blocking this thread, you will block the different callbacks that can be called when the node is spinning. So the second option, which we'll do here, is to add a down callback for the future. Okay, so future add, and it's actually a functionality from the future object. So this has nothing to do with Ros2, it's from the future object. And we will add a callback function that will be called when the future is complete. So basically when the future got a result, which means the server has sent a response. And let's create a callback for that. Def callback call add to int. So we will get the future object, which will contain the response. And I will also put A and B, because we will get the future, but the future only contains the response, it does not contain the request. And the problem we have then is, how do we know which request was made for this response? Because maybe you will call this multiple times. So if you have many responses, you need to know which response corresponds to which request. So we will send, in this case, we will send A and B. Okay, so we will send the parameters we have for the request. And what we will do in that callback is, well, we will simply copy that code. We will get the, so let's put the correct indentation. We will get the result, okay, future.result, and it may also have an exception, okay, if things went wrong. So of course we will handle the exception like that. And we can replace node with self, because now the node is the class. Okay, here it's not request.a, it's simply A. Here it's simply B. Okay, and response.sum. So this callback will be called, and you can process the response. You can do whatever you want with this response and use a try-catch structure, okay, because if you get an exception, then this will fail. And now we can add the callback function here, but still we have yet another problem, is that if we just put the callback here, we can't put any other arguments, so we will only be able to pass the future object. Okay, so self callback add 2 ints. The problem if we do that is only the future will be sent. So what we will do is to use another Python functionality. From func tools we'll import partial, which will allow us to add more arguments to our callback. And that again is specific to Python, not Ros2. So partial. Okay, we have, of course, the first argument of partial will be the callback function, and then we will add different additional parameters. And we need to make the parameters match exactly that. So we will have A equals A. So the A here is this one, and this A is what we got for the request. And B equals B. Okay, so now the code is complete. As you can see, that's quite a few lines just to call the server compared to the server itself, which was really quite easy. It's a little bit harder, but it's okay, because that is actually kind of a template now that you will use for any of your client. Okay, you first create the client, you wait for the client, so you wait for the server, sorry. Then you create a request, you send the request asynchronously, you add a callback for the future, and then you process the result in the callback. Okay, so for every new client you create, you will be able to copy and paste that basically, and you will not have much effort to do. So now if we just start this node, well, nothing will happen because we simply initialize it here. We haven't called this function yet. So that's what we'll do here. Self call add to int server with, let's say, 6 and 7. Okay, so we will start the node from the main. This we call the server, and then the node here will spin, and when it spins, it will also be able to receive the response from the server. And what's great with that code is that you can add here subscribers, publishers. Well, you can just write your node with other functionalities, and the code for the server will not block anything else. So we make sure that we can install add to int client my Python package and main function. We add a comma. Okay, so we can now build and install the code. Let's run the server and let's run the client Ros2 run. So we can source bash s because it's a new file. Ros2 run my Python package and add to int. So if I press tab twice, we see that we have two clients. I will just call the client with OOP and let's see what we got here. Okay, so it's working. We have the line on the server and the line on the client. Okay, so great. You have now one code just for writing a quick script like that, and then you have one part of code that you can use for any of your service client. And here actually, if we want to call the server multiple times, it's quite easy to do that. Let's put different parameters, 2 and 5. Okay, if I call this, so I can start it again because I use the symlink install. Great, we have 3 calls that are running one after the other, and here we have the processing from the server. So this way to handle clients in Ros2 is not the only one. As you can see, we already have 2 ways to do that, but it's a good one to start with. In this lecture, you will